Behold, the electric motor in all its glory. This actually is more than just an electric motor. Really, this is the electric motor. If you want to know more about it, watch the optional video. But if you look in here, this is a gearbox to slow it down and make it more powerful. So if we put this guy in there, notice we got two metal flaps on it. This is kind of standard for an electric motor. If you make one of them positive and the other negative, it'll turn in one direction. If you switch which side is connected to positive and which side is connected to negative, it'll turn the other way. So, very complicated device. So, notice I am using a small little battery pack here. This shouldn't be enough to burn out the motor. Just two AA batteries, each one's 1.5 volts, so in total we got 3 volts here. So if we touch one, so we can make it turn one way by connecting positive to this side and ground to this side. And what happens if we switch it? Let's take a look. Oh, notice it's rotating the other way if we switch which side is positive and which side is ground. Interesting. Oop. Hopefully I'm not shorting. There we go. That is your electric motor. Things to avoid doing. If I turned it on and held this stopped, so stopped it from turning even though it wants to, that is bad for the motor. That makes the tiny little wires in it heat up a ton more. It all has to do with something called back EMF, or back electromotive force. Basically, a motor is the same as a generator. So if I spin this, it'll actually generate electricity on both these. One of these will become positive and the other will become ground. And so as it spins up, it starts to fight the batteries, so not quite as much current flows through it once it gets up to speed. So the time when it's generating the most heat is when it's just starting out, if it's just stopped. So if you hold it stopped, it just keeps generating a ton of heat for a long time, which can build up to the point where it's bad. Don't do that. Any other things? Also, later on, we will be powering it. See, this was two 1.5 volts together in series, which gave us 3 volts. Here we've got 6, which is 9 volts. 6 times 1.5 is 9. That could be a bit of a problem later on if we don't control the power to make sure it doesn't burn our motor out. So you could think how, well, we can't vary the voltage, but maybe we can do something with analog right and duty cycles. That might be a way to, if we can't reduce the voltage going through it, maybe if we could just reduce the amount of time it receives the full voltage. So if it's receiving twice the voltage it should have, but only like half the time, it'll generate half the heat as it would if it was on all the time, and it'll be half as likely to burn out. So there you are, the electric motor.